Okay, is there any question that comes into your mind you'd like to ask? Okay, if not, okay, I share out the OneNote. Okay, we have done, okay, the other day until question number 5 here. Okay, complete the question number 5. Question number 6 here. Right. Now, Chang Wai, okay, Chang Wai have already done it. Part of it. All right. So they say figure question 6 here shows a synchronous circuit. They ask you to complete the state table showing on worksheet. Okay. Use the direct binary state assignments. That means S1 is represented as 0, 1, and so on. Okay. Then draw the state diagrams. So this is the question circuit given to me as in this form. Now they label the label indicating, okay, same input comes to here. And then they ask me, okay, for the next states and so on. So for these parts here, let me just double check here. So it would be good, okay, for us to sort of come out the expressions, okay, for the case of a J and K here, rather than just look at the diagrams. So this is what Changwa is doing. So he wrote down the Z, okay, is given by this part. All right. Z is given by this equation, X XOR with Q2. Okay. And what is our K1? So I just write here, K1, same as my X. Okay. Then J1, same as my, this X. Z2. All right. This one here, J2. Yep, he wrote it inside here. No wonder I cannot find just now. So X2 and K2 is the same as X K2. All right. So we based on these expressions here, we fill up this table. Okay, the next state table. So they arrange it in this form for us. Okay, this question I take it from last time your seniors, okay, they sit for external exam arranged by UK. All right, so they have this question, so I just stick it down. We can try to answer these questions. All right, so state S0 is labeled as this one, and for the case of J1, for example, J1, you are going to find that, okay, I go according to my X, when my X is a 0. So all this will be 0. Sorry, I see the wrong one. K first, K, all will be 0. Then the J also, because X is a 0, so you find that all are 0 over here. So for this case here, K2 also 0. All right. And J2, when one of them is a 0, so you get that all these are 0. Okay, next look at X is a 1. X is a 1. This one, all 1. And for the case of a J1, depends on Q2 now. Okay, because X is a 1, so depends on Q2 now. We go and check the Q2. Q2 is 1, 1. Okay, so 0, 1, 0, 1. So you find that here, written here as a 0, 1, 0, 1. Same as Q2. This one, same as Q2 bar, the terbalik. All right. Terbalik means it's J2, J2, okay, Q2 bar. And when Q2 bar is a 0, okay, we follow Q2 bar. Otherwise, okay, if Q2 bar is a 1, X will also be a 1. Okay, so let's check here, Q2. Q2, first one, X is a 1, Q2 bar become 0 will become 1, so correct. All right. This one here, once you put it in here, Q2 bar. So Q2 bar. Q1 bar or Q2 bar? It's Q1 bar. All right. Sorry, I see the wrong one. It's a Q1 bar. No wonder I check how come my answer is not correct. Okay, it's a Q1 bar. Sorry. So Q1 bar. So 0, 0, then change to become 1, 1. So 1, 1 change to become 0. All right, so we got this one already. Then once we got this, okay, we can work out what will be the next state. No change. This one also no change. All these are just no change. Therefore, you copy. Okay, label this one. This is S0, S1, S2, S3 in this column. And this part here, we need to work out, okay, based on for this. So 0, 1, reset. 1, 1, you toggle. So from originally is a 0, you toggle it become 1. So this one also still toggle. Originally is a 1, you toggle to become 0. This one originally is a 0, you toggle it to become 1. All right, and label this. Okay, then the Z, okay, based on the equation written on top here, okay, is X XOR with Q2. Okay, filled up and got this. Wow, based on equation filled up. Okay, that is this first part here. Second part here, draw the state diagram for this circuit using the skeleton provided. Skeleton is at the bottom. All right, so either you put it as a 0, 1, 0, 0 or use the S to represent. So they give me all these 4 already. So it's up to me to fill up based on here. So I checked already is correct. Okay, everyone okay? Is this correct? Okay, I don't think I need to explain this part. Okay, so done for this parts here. Then later on they ask me to complete the timing diagram provided. Where is the timing diagram? This is the one. Okay, this is a timing diagram that they supplied to me and asked me to fill up this table here, or this. All right, so we analyze this circuit again, check whether this one here clock, okay, falling edge, clock falling edge. All right, so if it is falling edge, okay, then you find out, okay, I put a mark here. I need to pay attention to this part. And these questions here, they also highlight for me already. Okay, draw the projection line. And this is the input conditions that they give out for the case of my X. Okay, so now I need to work out for my Q1, Q2. So maybe I just check this part here and put it at the side so that we can see it. Later on I delete. Okay, so I need to fill up this part here based on this table. So initially, okay, Z X is 1. Okay, so I'm supposed to find out, okay, what is the condition for my X1 and X2. Question never tell me, okay, whether the systems here will start from 0 or start from 1. So I think, okay, is a good assumption for us, okay, to say that, okay, it start from 0 because question, okay, start off by giving me, okay, S0 here. Okay, so I'm going to start, okay, to play safe, okay, I'm going to start to tell you here, I'm going to assume that, okay, assume that This one they use is Q1, Q2. Q1, Q2 equals to 0, 0 initially. Okay, so that we've got no arguments. The question never tell me. So I'm going to start off this one here with both are 0. Until the rising edge come. Sorry, falling edge come. Falling edge come because x is a 1, so I need to check here. X is a 1. They are going to go to 0, 1. Okay, 0, 1. Which one is 1? Which one is 2? 2 is at the back. Okay, so this is 2, this is 1. Okay, so they are going to, okay, when x is a 1 here, because they check conditions of x, now is a 1. We initially 0, 0. The next step you are going to go will be 0, 1. So here will be 1. For 2 will be a 1. For 1 still remain as 0. Then next, check again. My x now is a 0. And currently I'm at the state of 1, 0. 1, 0. Okay, what is the next state? If x is the, am I see the right one? Sorry, this is 1. So currently I'm at 0, 1. Okay, 0, 1. Then the next state, okay, that they should go also 0, 1. Also 0, 1 when x is a 0. This one, x is a 0. What is the next state? 0, 1. So I continue this. Okay, I continue this. Okay, check again. Still, okay, 0 for the x input. So I'm going to remain here as 0, 1. Okay, no change. We are looking at this. Then now x becomes a 1 here. You are at 0, 1. And x is a 1. You are going to go to 1, 0. X is a 1. You go to 1, 0. 1, 0 is this one. 1, 0. 1, 0. Okay, this is the 1, 0. Then check again. I'm now at 1, 0. X is a 1 comes in. Where do I go? I go to 0, 0. So I go to 0, 0. Okay, so this is a waveform for my next state. And one more I need to show is the Z. What is the Z conditions that we are having just now? Z is given as, maybe I put here, Z is X XOR with Q2. And Z in this case here is combinational. Z is combinational. They don't depend on the clock. Okay, they don't depend on clock. So, okay, clock independent. Okay, clock independent. So what I need to do is direct. Okay, so either one is a 1 will give me a 1 output. So X is a 1, Q is a 0 in this case. In this case, you find that my Z will be a 1. Okay, until here. Then now this part here, both are 1. XOR gate, both are 1. They are going to give me 0. Next, either one here is a 1. It's going to give me output me a 1. Either one is a 1. Give me a 1 up to here. Then now you see both are 1 again. For XOR gate, output is a 0. Then next, okay, here are either one is a 1. So this is the output that I'm having. Any questions? Combinational circuit. All right, so it don't depends on clock. Anyone with any questions? Let's see whether any. My mouse is not working. Okay, let's check. Anyone got any question? Someone no question. What about the rest? Someone must be thinking very hard, okay, to try to draw out the waveform. Huh? The rest, any questions? Okay, now this part here done. Then let's see, okay, what does the question want some more. So in this part here, I complete the timing diagram done. All right, now explain what is meant by the term force output. State if you consider that the output Z of the counter in this figure here has a force state. And if so, indicate this on the timing diagram in part C above. Okay, so this part, what do they want? Force output, output and Sala, okay? Now, is there any force output in our this design here? And maybe we look at this design, and also maybe we look at these okay, we look at these tables output compared to the waveform that I draw. Okay, compared to the waveform that I draw. I told you that this part here is combinational, independent of the clock. But when I filled up this table that time, okay, for the case of my Z, okay, I actually, depending on the conditions on these X as well as these states over here. And these are states over here, actually depending on the clock. So double check that, okay, my this answer is it tally with this result. Okay, very difficult to see. Never mind, we cut this one a bit. We only want to see no, sorry, cannot. Okay, let's bring this one here further in. If I put here, okay. So I think I can see already. Yeah. Okay. So let's compare this waveform that we draw just now with these state tables that we obtained. Okay. So you find that, okay, for me to get 1, I focus on the Z equals to a 1 here. You find that, okay, I need to be at the state of 0, 0. Okay, 0, 0. X is a 1. I got a 1. No problems. This is correct. Okay, this is correct. Okay, so when this is a 1, 0. Okay, this is a 1. This is 0 the time. This is a 1. So it's a 0, 1. Q1. Okay, 0, 1. X still a 1. Okay, I repeat here, 0, 1. Okay, X still a 1. All right, then you take it as a X still a 1, 0, 1, X still a 1. By right, I should get a 0. Yes, this part I correct. But in the middle, okay, you'll find that this one here changed to 1 already. Based on these equations here, you are going to find that my this part here is a 0. Then, okay, later on, maybe it become a 1. Then you are going to find out, okay, with this part here equals to 0. This is our 0, 1 again, 0, 1 again. X is a 1, sorry, X is a 0. Yep, I got a 1. So this is the part. I got a 1 here. Okay, until here again. Now, this is a 0, 1 again, 0, 1 again. X is a 1. Okay, 0, 1. X is a 1. Okay, I repeat, 0, 1, X is a 1. Okay, 0, 1, X is a 1. It should be a 0. Okay, 0, 1, X is a 1. It should be a 0. Also, good. Follow. All right. Then this part now, 1, 0. Okay, 1, 0. My X is a 1. X is a 1. Give you a 1, which is also correct. When 0, 0. So this part here, okay, when 0, 0, X is a 1, 0, 0, X is a 1, they also give me 1. All right, so where is my false output here? So that is to say, okay, if I draw, okay, I'm going to find that these parts here, if I base on this table, I'm going to base on this table that time, I draw these parts here. Okay, this is the output that I'm going to obtain rather than a 1 here. The rest are the same. Okay, the rest are the same. Okay, so the red color is this one, green color is this one. So now back to the questions. What do the questions say? Explain what is meant by the term false output. Output yang salah lah. Alright, okay, by right, okay, output should be a 1. Now they give you a 0. Or by right, it should be a 0. They give you a 1. Alright, state if you consider that the output Z of the counter in this one has a false state. Answer yes. Okay, because okay, if you are doing this, okay, automatically, okay, the system will know that, okay, this one here is combinational. Okay, I output you a 1. But over here, I don't want this one to be a 1. I want it to be a 0. Then now, next question is how to, okay, how to solve this problem. Indicate this on the timing diagram. I already done above, okay, the red color one. Okay, next step is explain how this circuit can be redesigned to eliminate the false state, the false output. Anyone with any idea? I want to redesign this circuit a little bit so that, okay, my systems here will not giving me the false output. Any suggestion from the class? Tan Wai? Tan Wai, any idea? How am I going to redesign this part so that, okay, I can get rid of the problem that I have just now? The whole problem come in is because, okay, this is combinational. They don't follow the clock. So in order to prevent these problems here, what we can do is this part, we make it also become synchronous. Okay, of course, use D. If you use other flip-flop, you are going to have problem. So we pass this X to here. And X only comes in, okay, controlled by the clock input. This one here, the original circuit here is the clock just coming as they like. So when they come in that time, all right, this one here controlled by the this clock. But this part here, no. So in order to do so, we also make this X input here controlled by the clock. If this is the active low, okay, or falling edge clock, I make sure that this part also using the falling edge, okay, clock as the control. Yeah. Okay, so of course, all these clock here should be connect together. Okay, these three clocks here all must be connected together. So the X come, okay, all will get the same X at the same time. Then with that, okay, you are going to find that your Z will not be affected, okay, and you will not be getting, okay, something like this one, the green color anymore. Okay, you are not going to get the green color this part, okay, you will get the red one. So this is what maybe I should highlight here. False output. Okay to all? Okay to all? So of course, okay, when this type of question come out, you write a little bit lah, okay, explain a little bit, don't just draw like that lah. Draw already, explain a little bit to synchronize, okay, the input X, okay, the input signal X. Okay, we consider we have done question number 6. Okay, then all these here are some past year paper. All right, I give a lot of questions on this waveform here because found that, okay, some students, okay, really find it difficult to understand. So, okay, give more questions on waveform. So this part here, nobody try. Okay, nobody try, so I also don't want to discuss. So this one here, positive edge, this is this one. All right, a positive edge trigger is shown in this one. If the input is as indicated, sketch the Q output waveform. Assume Q is initially clear. And okay, initially clear, so start from 0. All right, so this part here, let's see. As seen here is connect to our PR. PR is a preset. Okay, it's a preset. And preset here work on 0. In this case, works on 0 because I saw a bubble here. Clear also work on 0, but this clear here is not working because it's always connect to logic 1. So you can forget about this clear input because they always connect to logic 1. I only consider the preset, and next is the D. Rising edge, yeah. Okay. Preset not working. Correct. Initially low, preset not working. All right. So preset still not working. So come to here, preset is working. Preset is working. Then this one here, preset is working. This one here, preset no more working, but I see a 0 comes in. So I output a 0. Next. This one preset working again. Yup. Working again. I don't need to do until here. Yep, correct. Okay, so this is correct. Anyone with any questions? Okay, then this part here, 2 flip-flops connect together. One is T, the other one is D. I recheck, okay? I only put a tick on the first one. Only first one is correct. All right. How can first one and second one exactly the same in this case? Because this is a D flip-flop. Never mind. We look at it. Now, you find that, okay, both clear label as in this case here, they are connected together. Preset also connect together. So my preset, I want it to be 0. Clear also want it to be 0. So we highlight a bit here. All right, preset. Yeah. This one here should be rising edge, isn't it? Because I normally set question, I won't set it as an edge like that because our students will argue to prevent this thing from happening, okay? So normally, okay, I don't do it this way. All right, so this clock here should be rising edge, okay? Rising edge, So things will happen here. I check, okay, I didn't check the clock just now. So take away this tick here. All right, so anyway, we label first, rising edge. The blue color one, can I erase? Oh, can So anyway, it's wrong already. So never mind, just erase. Sorry, okay. I cannot. Respond a bit slow. Still like that. Okay, I think just leave it lah. Don't waste time on this. Okay, let me. So make it until very fine lah. Okay, so we also add in, okay, this maybe we use blue in this case here. This is the clear or the reset. This is the preset conditions. All right, so for this type of questions here, you look at one first. Don't do two at the same time. look at 1 first, because this one's output, okay, becomes the input to the D flip-flop. All right, so we look at 1 first. This one here always toggle. Okay, always toggle if preset and clear not working. So in these questions here, they never said about these initial conditions, but clear is working initially. So both, okay, both flip-flops here should start from 0. No doubt, because of the clear is working. Okay, clear still working. I say I now look at the first one here first. Clear still working. Okay, this one here got to use a little bit thicker. Okay, clear still working. Therefore, I still clear. Until the next clock pulse, you find that both not working, I toggle. Still not working, I toggle until here. Found that, okay, preset is working. Never mind, I continue. Still preset working, I continue. And then now both still not working, I toggle. Okay, toggle until here. Now clear is working, continue clear. Until here, yeah, continue clear. So this is the Q0. This Q0 is the input to the D flip-flops. Okay, input to the D flip-flop, but don't forget with a delay. Okay, with a delay. So what we are doing now is, okay, clear and preset, we still need to pay attention. So my clear is a 0, still clear, so continue to be a 0. Okay, so now this clock pulse comes in. They check what is the conditions here. It's a 0. What they checking is the one weighted in front. Remember the setup time? Okay, the setup time. This one happens, okay, you can say at the same time, but actually with a little bit of delay. All right, a little bit of delay. So actually, okay, the D flip-flop here don't see the input 1 at this instant. What they see, the input weighted there is a 0. So they are going to output you the 0. Only third clock pulse, okay, will see this 1. So they delay this 1 here. Fourth clock pulse will see as 0. Okay, then preset comes in at the same time for both. So this preset will make my output here become 1, 1 over here. Then clock pulse number 6, see that input here is a 1, so I continue a 1 here. 7, see a 0. So they pass this one, they pass to here. This one passed to here, and now found that, okay, clear is a 0. So I am going to clear the output. So this is the waveform that I should have for my Q. These are D flip-flops. Any questions? Think about it, okay? Any questions? This is where we say delay, D flip-flop, right? So delay. This one by right, they should delay, but because of the preset, okay, preset. So I preset the output. Okay, preset. All these are preset up to here, and this one come to this side. Okay, so preset and clear is the one that, okay, cause the pattern here do not take the input exactly the same as the output. Any questions? And this one here also, okay, this one here clear, only working. This clear, work on 0, clear. This one here. Okay, but I should clear, isn't it? Okay, double check this. So click on toggle. This one here must be a receipt paper. So go to one toggle because it's a flip toggle. Okay, then this one here I clear correct. Then I check here. Do you think this is correct? But nowadays, okay, no more receipt paper because they offer every semester. So all are main paper. Yeah, last time receipt is kept by C, ma. All right. So, okay, someone is going to correct it. So this part here, again, okay, is a mistake. Second one, okay. Someone do everything later on. Someone score. Someone got a very good mark for coursework. Okay, this one, I think someone also do corrections. All right. Maybe first one correct, the second one is not correct anymore. But remember, both are T flip-flops. Okay, so then I do correction. Okay, so I discussed most of the waveform diagrams already. All right, except I think this one you all never do. Those you never do, I never discuss. Okay, this is what we have done. Okay, like today. All right, we have multiplexer, we have D flip-flop, then we have this output Z here. So this question here didn't talk about false output, so I also sort of ignore this part. Okay, let's maybe I discuss one, so at least you all can try. Now, figure question 4 here shows a finite state machine. Finite state machine basically just tell you it's a sequential circuit. They are using two 4-to-1 multiplexer, 2 D flip-flop, and an AND gate. Story lah. Okay, this is a story. Okay, the finite state machines here having an input A. Okay, my input, external input is a A, and output is a Z, and the state Q1, Q2. Okay, assume that initially, okay, these two here are start from 0. Ask you to obtain the state transition table. Okay, obtain the state transition table, including A, Q1, Q2, Q1, Q0, then the next state of this Q1, Q0, and the output Z. Then later on, draw the Mealy state diagram for these finite state machines. Tell you the wrong story. What do they want? They want me to come up with a state table. Okay, the state table. So here got space. I can write here. So I can having okay this present state. Since they want state table, standard way, present state. So my present state here based on the Q1, Q0. Okay, Q1, Q0. And of course, okay, I will have my next state. And this next state here, depending on my this A bar, A is a 0 or A is a 1. So this next state here will be your Q1 plus. Wow, don't want to write this. Okay, and A equals to, this one here is a 0, and A here equals to a 1. Okay, next I'm going to put will be my output. Then again, of course, A equals to 0, A equals to 1. Okay, enough. So in this case here, question asked me to assume that initially, okay, these two are 0, 0. So I go and put 0, 0. Okay. Before I can fill in this part here, of course, I need to understand the diagrams. Okay. So maybe we work out here first. This one here, okay. let's call, because this is called Q1, so this is a D1. My D1 here equal to these equations, which this is a 0, 1, 2, 3. So it's the same as Q0 A bar. Okay? Q0 A bar. And of course, okay, this D1 now becomes input, will later on becomes your Q1. All right, next for this, you find that this is 0, 1, 2, 3, and this one happens at 2, this one happens at 1, so D2 is the same as Q1. This is 0, 0, 0, 1, Q1A. Okay, D2 is same as Q1A. Not D2, is D0. D0 is same as Q1A. Okay, so based on these equations here, I will be able to know what is my next state, because D is the same as the Q plus. Okay, Q1 plus. This one here, same as my Q0 plus. All right, so I put in this. So very fast, okay, we can do it. Now, this one here, A must be a 0. All right, A must be a 0, Q must be a 1, then only I got a 1. So for this part here, you'll find that, okay, we need to make the condition fulfill the expression, then we can fill in a 1 for the D1. We do the 1 first. Okay, A must be a 0. Yes, A must be a 0. Q0 must be a 1. Meet this requirement, isn't it? Then the rest not meeting the requirement, you fill up with 0. Okay, we also do this one for the case of 1 first. Okay, when A is a 1, you find that all never meet the requirement. Okay, so these two actually is my D1 Q1 plus. Okay, both are my Q1 plus. Next, I try to look for Q0 plus. So A must be a 1. Maybe I fulfill this one first. A must be a 1. Q1 is a 0. Q1 is a 0. A must be 1. Okay, A must be 1. Q1 must be 0. So Q1 must be 0. A must be 1. So you got a 1 here. Then next, okay, this part here never fulfill at all because A is a 0 already. Therefore, you have all this 0. Of course, this is the Q0 plus. Okay, my Z equation is given by A and with Q1. A must be a 1, Q1 must be a 1. Okay, so this one here never meet. Never meet. A is a 0. A must be a 1, Q1 must be a 1. Yep, this is the 2, 1 appear here. Q1, Q1. Yep, okay. So this is my obtain the state transition table done. Then the output Z. Okay, so this is the output Z. Then later on, okay, based on this one, draw the Mealy state diagram. Once got this already, draw diagram. So I start off with the initial state. Okay, 0, 0. Okay, when A is a 0, I stay, right? A is a 0. This is the input A. I stay and I output you a 0. This 0 and this 0 done. Sorry, this 0, these conditions and this condition done. Then if A is a 1, okay, I move on to state 0, 1. All right. And I also output you a 0. So this condition and this output done. Okay, finish for first one. Second one, I will move on to 1, 0. My diagram here may be a bit messy, okay, because if I didn't arrange it properly, it looks messy. Yeah. I will move on to 1, 0 if 0 is the input and output will also be 0. These two done. All right. So over here, I will stay. I will stay at this 0, 1 if input is the 0 and if input is a 1, if input is a 1, all right, input is a 1, but I still output you a 0. So I have done until here. Draw a line. That's easy for me to see. Okay, then at 1, 0, I'm going to go back to 0, 0. Go back to 0, 0. If it is A is a 0, I go back to 0, 0, output you a 0. But if A is a 1, I go back, all right, I output you a, I output you a 1. Okay, this is a difference. They both go back to 0, 0, but one output you a 0, the other one output you a 1. Okay, this 1, 1 here. So since it's going to go here, I'm going to draw it at this side. 1, 1. 1, 1. If A is a 0, I come to here. A is a 0. A is a 0. I come to here. I output you a 0. If A is a 1, they come to here. They output me a 1. Yeah, 1. Yeah, correct. Now, this is the table, or sorry, this is the state diagrams that I obtained based on this state table. You see, okay, these questions here set is reverse. Our normal design procedure is, okay, I understand the question. From the question, I transfer them to become a state diagram. I transfer it to become this. From here, come to here, then okay, go and work out and draw. Either use Carnot map or you use the Boolean algebra, then you simplify to draw this. But now this question here, terbalik. I give you this circuit. Please work out for me, okay? How does the state table looks like? How does the state diagram looks like? All right, so this is my solutions here for this part. So there are some more, okay, for you to try. Similar method, but this one here using 8-to-1 multiplexer. All right. Slightly difference a little bit here and there. I cannot set, okay, too difficult questions. Otherwise the student will go crazy. Okay, but teaching you these are techniques. All right, you can sort of do it. Okay, so try to get all tutorial done. Now, besides Chanwai, the rest please try. Otherwise, okay, you fail, okay? Then come on, first paper. If you fail the first paper, okay, the rest of the paper, your heart is not there anymore. All right, so I stop here. So we'll continue on Thursday at 11 a.m. So basically, okay, now will be all tutorial questions already. So like these are things here, I don't think, okay, I need to come up with lectures, okay? I just feed you with a lot of these tutorial. So hopefully y'all can no, get the techniques, understand? All right, so we stop here and see you again on Thursday. Okay, bye-bye and take care. May may or may not. Okay, Why? Because I already fit in a lot of these past year paper in the tutorial already. So if you all have any particular question, you all ask, okay, for the past year paper. Okay, test paper I didn't discuss, man. Yeah, talking about test paper, now I remember Wai. Lisa, sorry, Ren Jian, okay? Now, Ren Jian, just allow me to use this part here. So class, tell me, okay, can we, okay, do, let's say this is A, B, C input. Can we, okay, have our AND gate, okay, connected this way? This one all short circuit lah. Ren Jian and Ming Hang, I think, are two of them. Okay, macam never study this circuit before. I get so disappointed, you know. Ren Jian, check your test paper. Oh, I think the day you were not in. Okay, so I give out the test paper already. Okay, so please remember, next time if you do this one in the exam, okay, I straight away don't want to see 0 marks for it. So please individual input. This one is all short together already. So my output, okay, I also don't know what to call the output here. I never learned before. Okay, so if there's any question, okay, please ask on Thursday again. Okay, we stop here. And I say take care. Keep yourself, okay, make sure yourself is well until, okay, at least, okay, until the exam. Don't simply go out anywhere. Okay, because exam, once you tested positive, they won't allow you to sit for the paper and you're supposed to receipt. Okay, cannot erase, so let it be. So we stop here. Bye-bye.